Hello, my name is Joy Gianna Ross and I'm Head of Learning and Development for Neander Marine. And it's a real pleasure to have Ben Sherwood with us today to talk to us about the Dtorque specifications. Ben is incredibly experienced with over 26 years experience as an engineer. He's the Chief Technology Officer for Neander Marine, leading the engineering department. And a real pleasure to hear from you today, Ben. Thank you for being here.
Nice to be here, Joy.
Okay, shall we get started?
Yes, let's start.
So Ben, I can see a detailed technical specification here. Is there anything you can tell us about any of these points in more detail?
Yes, as you can see the detailed technical specification on the slide. I won't go through that. But the D-Torque 50 horsepower outboard utilizes two crankshafts, twin crankshafts for two cylinders, which is quite an unusual design. I'll go into more of that later. The engine is designed, tested, and manufactured by us at Neander Marine in our UK facility. And there's over 35 patents covering the unique features of this engine,
Right.
which is designed for optimal fuel efficiency and marine applications. Our UK factory has all the functions under one roof, including design, manufacturing, logistics, and testing. And we're not dependent on supply of engines from other manufacturers, so it ensures a more consistent supply of product and service parts to the marketplace.
Thank you. That's really interesting and an important point to mention. Thanks very much. Shall we move on to the next slide and look into this dual crankshaft in a bit more detail?
Yes, certainly.
I can see there's two crankshafts, as you mentioned before, and it is quite unusual. Is this an industry first, Ben?
It's a good question. In fact, one of the first recorded applications of an internal combustion engine fitted to a boat was by Frederick Lanchester,
Oh,
and
right.
he was a pioneer of the UK car industry, and his early engines utilised two crankshafts, but with opposing
Interesting.
pistons for smoother running. So the twin crankshaft marine engine has been around for a long time.
Interesting. So the benefits of this, as you mentioned, it creates a smoother and more stable engine.
Yeah, I mean, to go into some of the details, so the Neander design team, we selected the same design philosophy as Dr. Lanchester for the Dtorque product. I mean, traditionally, twin cylinder engines have a very high secondary out of balance force because both the pistons move up and down at the same time. Um,
Right.
so that adds mass to the crankshaft as counterweights, and this results in high out of balance forces when the piston is halfway down the bore. Um, but when two crankshafts are employed, the crankshaft balancing masses are equal and opposite to one another, so they cancel out a lot of these secondary forces, and the resultant out of balance forces are very low. So this technology results in a very smooth running twin cylinder engine, and certainly in our application it's smooth enough to be used with a tiller handle. So this is where the operator is, directly connected to the engine, but because the forces are so low, the out of balance forces, it's very comfortable and easy to use for long durations, long periods of time,
Okay.
even with a tiller handle system.
Thank you very much. That's really interesting. Great. Shall we go into one of the other specifications now?
Yes, certainly.
I can see here the spaceball design. What's a spaceball, Ben?
That's a good question. The Spaceball is one of the key patented technologies of the Dtorque product. Um, when Because we use two crankshafts and we have a conrod on each crankshaft connected to a common piston, and due to manufacturing tolerances, torsional vibrations in the crankshaft, we can't guarantee that each conrod is in exactly the same position over the full stroke of the cylinder. So to address this problem, we use something called a spaceball, which is effectively two piston pins mounted in one larger pin, which is free to rotate in the piston.
Okay, interesting. It sounds very futuristic, a spaceball.
And
Thank you for explaining that.
yeah, and there's some other points to raise on the spaceball, of course. So not only does it allow the engine to run, but because we allow a small amount of compliance and movement between each crankshaft system, we have very low side loads on the piston skirt. So this minimises friction, which in turn can contribute to lower fuel consumption and a longer service life. In fact, it's worth me pointing out that because the load from each piston is shared across two crankshafts rather than one, that the service life for the whole crank train is extended.
Right. Really important to note, and also really interesting to hear how the fuel consumption, which we've talked about before, how that actually translates into the design of the engine. How is it exactly that you were able to create the lower fuel consumption, so with the use of, for example, the spaceball design? So thank you very much for explaining that. Let's look at the next specification.
Yeah, of course.
The automatic thermo management system. So this manages engine temperatures, Ben?
Yeah, not only temperatures, but it's a combined system. So the Dtorque product has an integrated airflow system that draws clean air into the cowl through a ventilation system, which at first helps separate any water droplets from the airstream. Some of the air is drawn into an airbox and directed into the turbocharger of the engine, and a proportion of the air is drawn into a crankshaft driven fan, and this airflow is directed to cool the engine control unit, the alternator regulator, and also the area around the turbocharger. And this ensures that the temperature of the surface of the cowl is kept to a minimum for safe operation and handling.
Okay, so it reduces the risk of overheating and engine downtime, which is very important for people using the engine out in the field. Thanks very much. Okay, let's look at the next specification. See the aluminium cylinder block, which mentions is an aluminium design, of course, and it optimizes durability and it's lightweight and strong. How does it optimize durability?
Yeah, it's a good question. So one of the challenges of developing a lightweight turbocharged marine outboard engine is keeping the mass competitive with a gasoline product. This is a significant engineering challenge, because when you start using forced induction with a turbocharger, direct injection technology, and intercooling, those are components that are not part of a normal gasoline engine, and the addition of those components alone can be between 17, 18 to 22, 23 kilograms, depending on the size of the components. So immediately you're already at a disadvantage to be a comparable mass with a gasoline engine. So one of the things that we've done in the design of the Dtorque engine is focus on keeping the crankcase as light as possible. And one of the ways we've done that is to connect the cylinder head of the engine into the crankcase by using a very, very long bolt, and we bolt all the way through to the lower crankcase structure of the engine. So this is an effective way of distributing loads, and it results in the cylinder block being in compression from all of the bolt load. So we can realise a long service life whilst using the smallest amount of aluminium material as possible to keep the mass as competitive as possible.
A real benefit for the end user, thank you. Let's look at the next specification. Power trim and tilt. I can see here that means the tilting of the engine at a different axis level. Can you tell us why this is useful for the user, Ben?
Yes, the Dtorque outboard's fitted with a power trim and tilt system. It uses a DC electric motor to drive a hydraulic oil pump, and this in turn operates a set of valves to raise or lower the position of the outboard relative to the hull. The hydraulic system is sealed for a long operating life, and in fact this unit is manufactured in Japan by a company that specialises in this type of product for the marine outboard industry.
Oh, right. Right, really useful information there. Thank you, Ben. Shall we move on to the next specification?
Yes, certainly.
Cooling system we can see here. So it mentions here that it's an optimized oil cooling process. How does this work? It looks quite complicated.
Yeah, the cooling system utilises seawater or fresh water which is drawn from the inlet grills which are mounted in the gearbox to a semi-positive displacement water pump. The water pump's driven by the engine output shaft, so it ensures that cooling water is flowing at any time the engine is running. The water circulates around the turbocharger and exhaust manifold and the cylinder head initially until the water temperature reaches between 45 and 50 degrees centigrade. When this temperature is exceeded, there's a pair of wax thermostats that open and permit water flow around the lower area of the cylinder block and the remainder of the exhaust circuit.
That's really interesting. A nice diagram here which shows where the cold water comes in and the hot water comes out after that process has been completed.
Yes, and just to follow on from that, the water exiting the engine, as it's not so much hot water, as the water exits the cylinder block, it's mixed with the exhaust gas in the adapter plate, and that further lowers the temperature of the gas where it finally exits through the propellant. And you asked the question at the start, what about the special oil pan cooling? So in the Dtorque product, the oil pan is also surrounded by the cooling water, and a proportion of the water is not injected into the exhaust gas, is diverted around the outside of the oil pan, and this circulates and removes or controls the oil temperature and then exits this area through a siphoning system. So this ensures that the oil temperature is as optimum as possible in an outboard engine.
Fantastic. Thank you for explaining that so clearly, Ben. Shall we move on to the next specification?
Yes, certainly.
The deep gear ratio, Ben. What can you tell us about this?
Yeah, Neander selected this gear ratio, which further reduces the propeller speed but multiplies the torque at the propeller shaft. So this results in nearly 230 Newton meters of torque at the propeller at the peak engine torque speed. And typically we end up running the propeller between 1800 and 1900 RPM at peak power.
Okay.
So what does this mean? So at slower shaft speeds but a higher torque are suited to much higher pitch propellers. And this approach helps reduce friction losses through the propeller shaft. Because we are turning the propeller shaft at a slower speed, it doesn't result in a slower boat as long as the propeller matching that we talked about at the start of this interview is followed.
Okay. And so the meaning of this for the end user is that there's greater torque at lower revs, a reduced loss of power and more economical operation.
That's correct. That's correct.
Great, thank you. And let's move on to the last specification to wrap up this video.
Certainly.
The Bosch Common Rail fuel system. So have we partnered with Bosch to create this fuel system, Ben?
Yeah, we're very fortunate to have Bosch as a partner. It's enabled us to utilise the latest fuel system technology and package it for use in a marine environment. The system used by Neander has an oil lubricated crankshaft driven high pressure pump which delivers about 1,600 bar to the electronically controlled injectors. And an electronic metering valve only supplies the required amount of fuel to the high pressure pump. So again, this minimises the amount of power required to drive the injection system. This system, along with the design of the combustion chamber and cylinder head, enables the Dtorque engine to meet European emission standards without any exhaust after treatment. And the system is designed to run on normal EM590 ultra low sulfur diesel, typically between 5 and 10 ppm sulfur. And we can also run the engine on a biodiesel up to about 7% volume content.
Okay, really important points there about the actual specification of the diesel that can be used in this fuel system. And so for the end user, that means that it minimises noise, vibration and smoke by using this Bosch Common Rail fuel system.
Yes, that's correct.
Well, thank you so much, Ben, for going into great detail for us on the product specifications. It's been an absolute honour to hear your expertise and try and understand some of the very complex engineering processes that you have been creating with your team to produce the Dtorque. So thank you very much, and it's much appreciated.
You're welcome.